Today we'll be working on the Unit 7 test review. This is going to be all about systems of equations, and you can solve many of these problems using the substitution or the elimination methods. Let's begin. Number 1 has the equations x minus y equals 6 and 3x plus 5y equals 2. The first thing I always do is label these equations. So we'll label this A and B. For this one, I'll multiply A by 3 in order to match the 3x in B. So let's do that here. That means I'll be multiplying everything in A by 3. 3x minus 3y equals 18. And B will remain the same, 3x plus 5y equals 2. Next, I'll be subtracting. I'm getting rid of the x's, so same sign subtract, opposites add. Let's subtract these equations. The x's will subtract out. Negative 3y minus 5y will be negative 8y. And this is equal to 18 minus 2 is 16. Then I can solve for y by dividing both sides by this negative 8. Y is equal to negative 2. Once I've solved for one of the variables, I'll take this and plug it into one of these equations. So let's plug this into A. A is x minus y equals 6. But I now know that y is negative 2. So I can replace the y here and say x minus y is negative 2. And this is equal to 6. So x plus 2 is equal to 6. And when I subtract 2 from both sides, I'll find that x is equal to 4. All right, number 2. Let's see, I've got 2x plus 4y equals negative 2, and 5x plus 7y equals 1. Here, I don't have anything that I can multiply a by, at least an integer, to get either 5x or 7y. So what I might have to do is instead multiply a by 5, let's say, the coefficient on x for b, and multiply b by 2, the coefficient on x for a. So this will be 5a and 2b. Okay, so 10x plus 20y is equal to negative 10. And 10x plus 14y is equal to 2. Again, same sign subtract. So we will subtract these equations, subtracting out the x's. 20y minus 14y will be 6y, and this is equal to negative 10 minus 2 is negative 12. Let's divide both sides by 6. Y is equal to negative 2. Now we'll take this and plug this into either A or B. Let's try A again. So that'll be 2x plus 4y is equal to negative 2. Y is negative 2, so 2x plus 4 times negative 2 equals negative 2. 2x minus 8 equals negative 2. Let's keep solving. So we'll add 8. Two x is equal to 6. And dividing both sides by 2, x is equal to 3. All right, let's move to number 3. For number 3, I've got 3x plus 5y equals negative 11, and 5x minus y equals 19. So here, whenever I see a variable with a single x or a single y, or in this case, negative 1y, I really like that because I can just multiply by whatever the coefficient on that variable is for the other equation. In this case, I'm going to keep a the same, but multiply b by 5. So a will be 3x plus 5y is equal to negative 11. And b, multiplying everything by 5, I'll have 25x minus 5y. This is equal to 95. Okay, these are opposite signs. So same sign subtract, opposites add. We'll add, subtracting out the y's. We're left with 28x is equal to negative 11 plus 95. That's going to be 84. And divide both sides by 28 to solve for x. X is equal to 84 divided by 28 is 3. Then go ahead and take this and plug it into one of your equations. I think b would be easier. So I'll have 5x minus y is equal to 19. X is 3, so this will be 5 times 3. Then minus y is equal to 19. 15 minus y is equal to 19. Subtracting 15 from both sides, I'll get negative y is equal to 4. So this tells me that y is going to be negative 4. Okay, for number 4, I've got 2x minus y equals negative 1. Negative 4x plus 2y equals 2. All right, let's multiply a by 2. See what happens. So 2a and then b. This will be 4x minus 2y equals negative 2. And then b stays the same. Negative 4x plus 2y equals positive 2. I'm getting rid of the x's here, so we'll add. But what I notice here is 4x plus negative 4x, x's will subtract out. Negative 2y plus 2y, the y's will also subtract out. This leaves 0 on the left side of this equal sign. So 0 equals negative 2 plus 2. That also is 0. When this happens, when you go to solve these problems and you end up with 0 equals 0, this tells you that you'll have infinite solutions. In other words, these two lines are actually the same line. All right, let's keep going. On the second page, number 5 is 2x minus 3y equals 2, and x plus y equals 6. Let's try solving this one using substitution. So when I use substitution, I pick one of the equations and I solve for a variable there. So let's use equation B, x plus y equals 6. And let's solve for y. So let's subtract x from both sides. So I'll get y is equal to negative x plus 6. Now what this means is in this system, where these two intersect, assuming they intersect, every time I see a y, it is the same as negative x plus 6, that whole thing. So I'm going to go to equation A, and I'm going to plug in y equals negative x plus 6. So A is 2x minus 3y equals 2. And when I go to plug this in, this will now read 2x minus 3 times the quantity, negative x plus 6, and this will be equal to 2. Let's distribute this negative 3. 2x plus 3x minus 18 is equal to 2. 5x minus 18 is equal to 2. Let's add 18 to both sides. $5x is equal to 20, and then divide both sides by 5. So x is equal to 4. Now, once you've solved for one of the variables using substitution method, you have to plug that into the other equation. So I solved this using equation A. I'm going to plug this into equation B. So let's write B over here, and I can actually just use this one. Y is equal to negative x plus 6. So let's plug that in. Y is equal to negative 4 plus 6. So y is equal to positive 2. Okay, for number 6, I've got 4x minus 2y equals 5. And for equation B, 2x minus y equals 1. Let's multiply, let's try to get rid of the x's. Let's multiply b by 2. So this will be a and then 2b. So a will stay the same. 4x minus 2y is equal to 5. For b, this is 4x minus 2y is equal to 2. All right, let's go ahead and subtract. Same sign, subtract. 4x minus 4x, that'll go to 0. Negative 2y minus negative 2y, that'll also go to 0. So on the left side of this equal sign, I'll have 0. So 0 is equal to, and then 5 minus 2 is 3. 0 equals 3. Now this is a false statement. When you go to solve here and the variables subtract out, leaving just 0, and it's equal to anything but 0, so this ends up being false, this tells you there's no real solution. All right, one more problem. This time, this is a system with 3 equations and 3 variables. Let's again start by labeling. This will be A, then B, and then C. Then you want to pick two of these equations and eliminate one of the variables. So you get to pick. I think it would be easiest to eliminate z. I can select a and b, and I don't have to multiply either of them by anything. I can just go ahead and add the equations together, since my z's, my coefficients, are exact opposites, -1 and +1. So let's start there. A and b. A is 4x, or just x, minus 4y, minus z is equal to 3. B is 2x minus 5y, plus z is equal to 0. I'm going to add these together, subtracting out the z's, and I'll get x plus 2x is 3x. -4y plus -5y is going to be -9y. And this is equal to 3 plus 0, so 3. 3x minus 9y equals 3 is a brand new equation, so I'm going to give it a new label. I've already used A, B, and C, so I'm going to call this D. And I'm going to highlight this. Let's highlight this in yellow here, because I'm going to be using this later. Then what I want to do is pick a different combination of equations. So I've already used A and B. I can use A and C, or I can do B and C. Let's see, if I do B and C, I would have to multiply B by 2 to get 2z in order to subtract out the z's. So let's do 2b and then c. 2 times b is going to be 4x minus 10y plus 2z is equal to 0. And then c is exactly as it reads. 3x minus 3y plus 2z is equal to -1. Same sign, subtract. Let's subtract these equations. Z's will subtract out. And I'm left with 4x minus 3x, so this will be a single x. -10y minus -3y is going to be -7y. And this is equal to 0 minus -1, so +1. X minus 7y equals 1. This is a brand new equation. Let's give it a new label. A, B, C, D. We'll use label E. Okay, now look at the highlighted equations. Equation D and equation E. If I ignore everything else, this is a system of in itself, 2 equations, 2 variables. What I'm going to do is solve this just like I did all of the others. So if I wanted to get rid of the x's, I could multiply E by 3 to match the 3x in D. Let's do that over here. So we'll have D and then 3e. 3x minus 9y is equal to 3. 3 times e will be 3x minus 21y is equal to 3. Same sign, subtract. X's will subtract out, but so will the 3's over here. So you're left with -9y minus -21y. That's going to be 12y is equal to 0. Now I can go ahead and solve for y. Divide both sides by 12. Of course, 0 divided by anything is 0. So y is going to be equal to 0. Once you've solved for one of the variables here, you're going to go back to your highlighted equations. These are the ones that you found. And you're going to select one of them and plug in y equals 0. If I pick equation E, that means x minus 7y equals 1 will now be x minus 7 times 0 equals 1. Okay, negative 7 times this 0. So that will just be 0, and I'll have x is equal to 1. Lastly, once I've solved two of the variables, I'm going to take those two and plug them into one of the original equations. So I can pick equation A, looks to be the easiest one. So A is x minus 4y minus z is equal to 3. And I now know that y is 0 and x is 1. So let's plug those in. This will be 1 minus 4 times 0 minus y, or minus z. This is equal to 3. So we'll have 1 minus z is equal to 3. Let's subtract 1 from both sides. Negative z is equal to 2. And so dividing both sides by negative 1, I'll get z is equal to negative 2. All right, and that is it. Hopefully that helps you out. If you have any questions, please let me know.